Yeah, so I'll be talking about some of the work we've been doing on, let's say, diagnosing lower than expected HTCs over the past, let's say, 7 years, something like that. We've been doing our fair share of co-heating tests. So a lot of local social housing corporations are looking for, let's say, affordable but also good renovation concepts. Certain social housing corporations in the Netherlands own about 1/3 of the residential building stock. They are really expected to take a leading role in the energy transition of the built environment. But before they're going to renovate 100,000 or 1 million houses with certain renovation concepts, they of course need to know what really works and what doesn't. So we've been doing a lot of co-heating tests to establish that. Mostly retrofits, but we've done some new builds as well. The results we obtain vary quite widely. So in some cases we've seen that we reach the as designed, so pre-retrofit HTC, but others are falling short and sometimes quite dramatically. And I'll just show you some examples, starting with a good one in a sense. So these are very typical Dutch houses, terraced houses built in 1972, cavity wall constructions, a lot of brick, and of course the thermal performance of those old buildings is quite poor. So what we can do is we can pre-manufacture insulation packages for both facades and roofs, and we can just install them on those buildings in 1 or 2 days. It's very quick, and then you'll end up with an end result like that. So I mean, it looks fresh, right? So what we've been doing in this case for this local housing corporation is doing some pre and post retrofit co-heating tests. And that's always accompanied by blower door tests to assess the air permeability. So just from these figures, you could say, well, airtightness has improved quite a lot. I do have to make a note here because we actually measured differently in these 2 cases. So normally a standard blower door test is at the individual building level. What we noticed, however, is that there were quite significant air leaks between adjacent properties. In fact, when we were doing some smoke detection, the fire alarm at the neighbors went off. Those people were not happy about it. Now, you could say there's tons of reasons. Of course, you don't want very leak party walls. But from an energetic point of view, it's not that dramatic. Temperatures are more or less the same. We shouldn't have real big pressure differences between adjacent properties. So what we can do is in fact just pressurize those 2 adjacent buildings as well. And then indeed we find that it's quite airtight, at least towards the outdoor environment. But still, those leaks between properties are present. And of course, we did. That's too fast. We did co-heating tests as well. So we did those pre-retrofit and post-retrofit. So just looking at the numbers, well, the improvement is obvious. So we improved quite a bit. And in fact, we're also very close to the design value. Taking into account the uncertainties, you might even say it's spot on, right? So very good example. Of course, there's also some bad examples, and I really can't share too much detail right here because this housing corporation wasn't very proud of these results, of course. But again, a very typical Dutch terraced house, cavity walls, a lot of brick, 92 square meters, built in 1992. And rather than a whole, let's say, renovation concept, some smaller measures were applied to that building. So the building already had some cavity wall insulation and some mineral wool insulation from when it was built. And some UF foam was added to that. Some additional roof insulation was installed, and some of the glazing, there was still some single glazing in that building, was also replaced by modern glazing. And these are the results we obtained here. So in terms of air permeability, not really much has happened. But looking at, let's say, the absolute figures, it seems to have gotten worse, in fact. And we have hypothesized some reasons for that. It will take too long to discuss that now. We're happy to talk about it over lunch, but we know a few reasons. One of them, especially if you take into account the concept I showed you earlier, is thermal bridging is a very big factor here, probably. I'm saying probably because we want to investigate further. We need some additional measurements, some new value measurements, etc. But the Housing Corporation, in this case, more or less already discarded these solutions and weren't very interested in doing additional research on that. Another thing to take into account is these uncertainties. So uncertainties are, let's say, quite big, or they are relevant. And taking into account these uncertainties, well, I'm not sure whether it actually got worse, but I dare say it has not improved. All right. And that's another one, something I would like to discuss right here. It's quite difficult to do a good uncertainty quantification, right? I mean, it's one thing to take into account measurement uncertainties of sensor uncertainties. It's all right to do model uncertainties if you have a linear regression model or a gray box model, but there are tons of other things. Still using air temperatures rather than surface temperatures. In one of those co-heating tests, the period was quite sunny, so that will have impacted the end result. In an exfiltration rate, so the building, or let's say gaps in the building fabric, are not evenly distributed over the whole building, and neither are wind pressures. So it's really difficult to quantify that well. We've been doing some new builds, very, very wet construction, built from concrete, from plaster. So it's also difficult to quantify latent heat losses. I mean, I'm sure we all write very nice reports with very nice discussion sections at the end, detailing all the uncertainties that are available. But to really stick an accurate number to that, that's difficult. And what we also notice is that partners from industry often find it quite difficult to interpret uncertainty and also accuracy, I understand. So, I mean, there still could be some work there probably as well. Show you some deficiencies we've been noticing over the past few years. This is one of the remountable facades in our Smart Tidy lab. We'll visit there this afternoon. It's a wood skeleton construction, and it's built with a loose fill insulation material. We drilled a hole right here just to see if there's any sagging of insulation material. So when we drilled this, I could still barely see the insulation material there, but by now I really can't. And so it's sagged even further. And we can also see that on infrared images. So I mean, there's basically no insulation here. Let's say the top 10, 12 centimeters. There's a horizontal beam right here, and also there's sagging below that. We are moving in the Netherlands towards more bio-based insulation materials, and those materials are often, let's say, loose fill, blown in insulation material. So this is really something to take into account in the future. Another one, and I'll just go through this very quickly because I'm running out of time. But again, in this renovation concept, what they did is they integrated supply air ventilation ducts within that thermal shell, so in that insulation package. Well, of course, that means that the insulation layer at those ducts is a lot thinner than elsewhere. And of course, that has an impact on the HTC, but I'm not necessarily talking about that. We can take that into account when calculating the design value. But in fact, because you have such a thin insulation layer between the ventilation duct and the outer environment, you can actually have cooling down of ventilation air in winter. So we did some measurements. We put some temperature sensors in there. And in fact, we see that. So temperatures at the ground floor level are a lot lower than on the attic and on the first floor. So in fact, we are cooling down the supply ventilation air a bit. On the south facade, we see something different because on sunny days, you can see the global radiation in the graph below, it heats up somewhat. And that's also, I mean, in a sense, logical because that insulation package does not have a lot of thermal mass, of course. I mean, if you really do a model, do the calculations, you find, let's say, not extreme heat losses and heat gains. It's fairly small. But as we see more and more integration of HVAC components in the thermal building fabric, I think this is also something to take into account. I won't go through these in detail, but these are some of the key takeaways from this presentation. Thank you very much.
Thanks. Have your slides?
Yeah.
Grant our new native version.
Zie je Enschede een stuk lang erin. Ik zal daar veel op dit moment vertellen. Ja.
Yes, in compañero, lo conseguí.
Ja.